Hey, neighbors. Alright, so today we're looking at something called implicit function. Implicit. Everything you've been doing before now is explicit function. Explicit in the sense that one variable is expressed explicitly in terms of the other, without any mixture, without any doubt, directly in terms of the other. Oh, y equals 2x plus 1. That is straight. I don't think anything can be more straightforward than that. So because such a function, explicit functions. Okay, and that is everything you've been doing. So when you have an explicit function, u equals sine x, then you can find directly du dx. Understand? But we will run into some problems, either now or in the future, that it will be an implicit function. Currently, we can look at it from the equation of a circle. The equation of a circle is generally given by, I'll take this off when I'm done, x minus a squared, y minus b squared equals r squared, where a, b is the center and r is the radius in the Cartesian plane. When you expand this bracket, definitely you're going to have some x squared, you're going to have y squared. Is that not? You're going to have x term, you're going to have y term. Imagine having to make y the subject of the formula first before you find the gradient. Imagine being given the equation of a circle and you need to find the gradient at a particular point on the circle. Do you now, first of all, make y the subject and then differentiate? Remember, when you're making y the subject, there will be some square root clause somewhere. They have a relation there, not a function necessarily, by the standard of being a function, right? Then you have to differentiate with the square root. It's going to be so complicated. Even that can be done because you've learned how to differentiate even with square root. Chain rule will help you on that. But does it mean that every function that looks like that, you have to first make something the subject of the formula? There has to be another way out. What if you have something that looks like this? How is it possible to first make y the subject? Does it mean a graph of this function? Does it mean if you have a function like this, on the graph you cannot find a tangent at a point to be able to know the gradient at that point? Do you understand my point? So issues like this will come up. Maybe in future this guy is working on some economics problem and a model came up in form of a mathematical equation. He put it on the graph and he wants to find the gradient. Oh, this is an implicit function. I don't know what to do. Does it mean his work will stop at that point? No. So over the years, mathematicians have developed techniques to be able to find the gradient of such a curve at any point. Does that make sense? And that is what we are trying to do now. Okay? Now, so this is everything about implicit and explicit. I believe that is clear enough for us. When a function is explicit, one is directly in terms of the other. When a function is implicit, they are mixed. No variable is directly in terms of the other. As a matter of fact, you may not know which one is independent variable or dependent variable, because they are all just mixed together. Unlike in y equals this, you know that you have to substitute x to get y. So y depends on x, right? So we call y the dependent variable and the x is the independent variable. And also when you differentiate this by this, you always differentiate with respect to the independent variable. Do you understand? But in this case, they are mixed. You don't know who is the boss, right? Anyone could be dependent or independent, depending on what dy by dx says, depending on what you are differentiating with respect to what. Do you understand that? So if you find the y dx, it means you can find the gradient at a particular point x later, because your x is the independent variable, y is the dependent variable. Similarly, I could change it the other way around. Let the president be the vice president and the vice president go to the presidency and say, oh, I want to find the x, the y. Which means if I do that, I'm looking for the gradient at a point y is equal to something. I don't know if you are getting my point. So here, we don't know which is which, because we are looking at x and y because we are used to x and y. What if I give you something in terms of P and Q? What if you have V and S? Do you now say, oh, I don't know which one is which? This will tell you D what? This is your independent variable with respect to what? Am I making sense? If you forget, just write y equals ax plus b and think about it. Which one is easier to substitute to get the order? It doesn't mean the other one cannot be done also. If you get y, you can always get x from y. Okay, but by substitution, what are we used to from our P6, from our P4, or whatever class? That will guide you. Understand? Now, to differentiate an implicit function, f of x, y, I write it like this. This is an implicit function in two variables. You can have in three variables. In two variables because we are dealing with the Cartesian plane, xy axis. If you are dealing with a three-dimensional plane, it will be xyz. At the point in my research project, in my thesis, I mean, we were dealing with three variables. Then we are looking at maximum point. In that case, you are not talking about the line. If you are having a three-variable curve, I'll show you in one of the 3D app. Then you see something that looks like a surface, just like the Aladdin math, you know, something like that. So even at that surface, can we find the gradient? At least there's a slope, right? Can we find the gradient? For whatever reason, we are trying to find the gradient. Okay, and then we got stuck at the point. There's something called the Lagrange method, and it didn't work out. Then we had to do something else. And you know, going back and forth for months, my supervisor and I. Anyways, so these are the steps. There may be other ways to look at it, especially for this one. But here, just note the following steps. Number one, do not treat anyone like the x and y. Oh, this is a variable, this is a constant. No. Remember, if I give you y equals ax squared, a is automatically a constant in your dy dx, right? But then you already have your y and you have your x, so any other letter is regarded as a constant. Especially because it will be indicated a belongs to r, telling you that a is a number, a is a constant. Am I making sense? But here, there will be nothing like x is in r or y is a constant. No. So both of them are variables. And because they are variables, they have to be treated as such. So when you are differentiating, you differentiate both x and y. However, whenever you differentiate the independent variable, the dependent variable, which is y, the one at the top, whenever you differentiate anything that contains y, you must include the y dx. It sounds like, okay, I'll show you maybe in an example. You have to include that. So that is how to get by from the equation to the derivative step. And the rest is just to make the y dx the subject. I will start with very simple cases in two different examples, then I will take it to more complex cases. Now, your knowledge of chain rule, product rule, quotient rule applies. Your knowledge of exponential function, logarithmic function, trig function applies. The only thing we're saying is that whenever you differentiate y, include the y dx. Understand? Also, now, we'll do this, then we'll come to this. So for second derivative, one of the easy way that I found, I will demonstrate it there. But the first is to differentiate. I'll say you call that equation 1. Then the same line that you have differentiated, the same line you have, now when you differentiate, call that equation 1, yes. Then make dy dx the subject, just like following this. Call that another equation. Then go back to the first equation, of course after you have simplified necessary stuff, and differentiate again. That's easier than just telling you second derivative is kinikon. I don't really like some of those complicated ways, especially because you're in high school. The last thing we want is to start making you think like a year 2 student or year 1 student. Let's look at this. Here you will understand what I mean better. X and y are both variables. Only 7 is a constant. So you are going to differentiate the entire line. Derivative of x squared is 2x. There's no, y is not contained in what I differentiated. And I say, oh, what is the derivative of x squared? 2x. There's no y in what I'm asking what is the derivative of, right? So there's nothing for like dy dx. But here, what is the derivative of y squared? Oh, 2y. But because I'm differentiating a y term, you put dy dx. What's the derivative of 7? 0, because it's a constant. Understand? Remember, when you say d dx of whatever you have here, right? D dx of y is what we call dy dx, isn't it? So, if we say differentiate it, so basically we're actually adopting chain rule. In the sense that we have y squared. By chain rule of differentiation, this comes back. 2 minus 1. The y remains, isn't it? Then you differentiate the bracket. And the bracket is this. Am I making sense? And that is why you had dy dx to it. Just to make it easier, that's why I said when you differentiate the y term, include dy dx. Are you confused? Okay. I'm trying to justify why this. Not just you memorizing, oh, whenever I differentiate y, I must put dy dx. Let's look at it as chain rule. If I use chain rule of differentiation for x squared, for example, I get, let's write it in this way to make it look so big. By chain rule, if I want to find the derivative of this, I have 2 minus 1. This is my x, right? Then multiplied by derivative of x. So d dx of x is what? Is 1, right? We know that the derivative of x is 1. Why is that? Remember, this is like dx dx. We've talked about that when I asked you to flip dux dy to dy dx in the previous section. Understand? Understand? Now let's use the same for y squared. So for y squared, by chain rule, 2, that's 2 minus 1, right? Then multiply by derivative of this. Derivative of this is d dx of y. And this is actually dy dx. This d dx of y means dy dx. Remember, if I say y equals sine x, I could either say dy dx or I tell you to do d dx of sine x. Understand? So it's just notation. But to make it easier, we just tell the student, oh, whenever you differentiate a y term, you must include dy dx. But this is the reason. It's not just, oh, somebody brought it from the sky and we all have to accept it. Okay? So that's what I've done here. This does not contain y, so there's no dy dx included. This contains y, so you differentiate normally as if it is x to the power n. And after that, you must include dy dx. And this is constant, that's 0. Understand? So the next step is to make dy dx the subject of the formula. So I get 2y dy dx equals negative 2x. You okay? You're not having a smiley face, what's going on? Is it food? Or is it coffee? Coffee, okay. Because you have a sad face. That's unusual. Can you see that? So it is. So your derivative will be a mix of both most of the time, of course. Okay? Now let's take another. Let's mix it a little bit. X squared plus 2x plus y squared plus maybe 3y minus maybe 9 equals to 0. Are you paying attention? Do we need dy dx here when we differentiate? No, so that's just 2x. Do we need dy dx here when we differentiate? No. So what's that? 2. Do we need dy dx here?
Yes.
Yes. So that's what? 2y dy dx. What about this one? Yes. So that will be 3 dy dx. Do we need it here?
No.
No, that's 0. Derivative of 9 is equal to derivative of 0?
0.
0. That's also a constant. Everyone is invited. Treat everybody equally. Whether they fail or pass eventually, it's up to them, but at least treat them, be nice to people. Okay? So we have dy dx in two places. 2y dy dx plus 3 dy dx is equal to negative 2x negative 2. Yes or yes? Yes. Then you factorize. Okay? And that is negative 2x plus 1 and s straight equal. So dy dx is now negative 2x plus 1 divided by 2y plus 3. So if a question say, oh, find the gradient at point 1, 0, then you substitute x is equal to 1, y is equal to 0 here, and that's your gradient. So the first derivative is easy, okay? I intentionally haven't done the second derivative. I want us to do some first derivative first, then I'll put the second derivative beside it. So let's take one or two more with some rules. If you need to stand, please stand. Do not sleep. This is very important. I don't want you to struggle with it later. Okay, please. Let's do the second derivative of these two first. You're not listening, young lady. You're not listening. And I'll hate it if you ask me an unnecessary question later. Let's do the second derivative for this first. For the second derivative, I said differentiate. This will be my equation 1. And this will be my equation 2. After I differentiated, I call it equation 1. Of course, if everything is out of place, you need to simplify. For example, you have 2y bracket 3x bracket dy dx. You need to write it as 6xy dy dx first. Understand? Okay? Dude, class, mute. Shut up. Okay, here also, like this one, my equation 1 should be this is equal to 0. That's what I'm trying to say. So try to simplify better first. Okay, so go back and differentiate your equation 1. From here, for dy dx, so careful. From equation 1, differentiate this, you get 2. There's no dy dx. But to differentiate this, did anybody notice something? Product rule. 2 is a constant. And now you're having this as your u and this as your v. Okay? By product rule, v du, u dv. Right? V means copy and paste v, the way you see it. Copy and paste dy dx. Du means differentiate u, which is y times 1. Do I stop there? Times 1 what? Come on. Dy dx. Okay? Should I go over that again?
Yeah, can you go over?
Raise your hand if it's okay. Oh, raise your hand if you want me to go over it. Okay. This part, I can make u my 2y. But I could just say 2 is a constant. Either way it will work. Okay? So I make 2 separate, then I want to differentiate this. So I have u and v. My 2 is a constant. By the rule of differentiation, you can keep 2 away. After that, then it's multiplying. So This, right, note this. This means just copy and paste. This means differentiate. Copy and paste v, dy dx. Differentiate u means differentiate y. Of course, that's 1. Then dy dx, because y is what you have just differentiated. Then plus, u means copy and paste y. Differentiate dy dx, what do you get? d2y dx squared. Remember, second derivative is the derivative of the first derivative. Understand? Is equal to differentiate 0, still 0. Very stubborn guy. Understand? So then we simplify this. Remember, we have our dy dx, which we have already obtained. That's why in that instruction I said you need to substitute what? Differentiate 1 again and use equation 2. So equation 2 will contain your dy dx. Even if the question says find the dy dx squared directly, you will need dy dx. Because when you get here, dy dx might just come up. Okay, so this will be 2 plus 2 brackets negative x over y, negative x over y, y d2y dx squared. You can open the bracket first before you substitute, it's up to you. So this is from equation 2. So this is what we simplify and make this guy the subject, and we have just found the second derivative. So if I open a bracket, this will be plus. So I get 2x squared over y squared, correct? And here we get 2y d2y dx squared is equal to 0. Okay, so if you isolate this one, 2y d2y dx squared equals negative 2x squared over y squared, which I can merge as y squared. Actually, since negative is common, can you see that? Do you agree? Will it be okay if I just write this? Is it okay? Everybody understand that? Okay. Finally, this will come here. Actually, from here, I could have just cancelled all the 2's. Okay? I can divide through by 2 here. That's better way of simplifying. So this will just be 1, or you don't have to do that here. We can do it here. So I'm going to have d2y dx squared to be negative 2y squared plus x squared divided by 2y cubed. Yes? And the 2 can be cancelled, so you get that. And that's your second derivative. Similarly, let's do for here. So this is automatically 2x plus 2 plus 2y dy dx plus, actually, this is more simplified. Right? So instead of differentiating this, differentiate this product rule, yeah. I think both will work. Both will work. Don't worry. I can call this my equation 1 and call this my equation 2. You can actually try to use this too. But remember, you have to use like quotient rule. I just believe that would be too complicated. So that's why I encourage you to go back here. It's easy to use product rule, right? And differentiate term by term than trying to manipulate this. Okay? Alright, so let's differentiate this one from 1. Is this product rule? Talk to me, please. Yes. Is this product rule? Because this is a constant, so not product rule. Is this product rule? How about this one? It's only one product rule. So instead of 2 bracket this time, I'm going to call this U and call this V. It's the same. Okay? You can either follow this or you can do that. It's allowed. So let's go together from equation 1. Yes? Let's follow that pattern. Copy and paste, dy dx, thank you. 2 dy dx. Is that clear? Raise your hand if you understand that. Thank you. Okay, plus 2y d2y dx squared. So that's product rule. Do I need to put some bracket? No. There's nothing here to multiply. There's no negative, so the bracket is redundant. It's like we're employing somebody who's not doing anything. That's a redundant staff. Just open a charity and give them money. You know, rather than tell them waste their time to come home, wake up very early, let them just sleep till 9, send them money. Okay. Plus, what is the second one? Derivative of this? Talk to me.
I need to hear your voice. You're not talking today. What's going on? Do I need to go to Starbucks and get coffee for you? Okay.
Alright. 3, d2y dx squared. Thank you. Then what next?
Minus 2.
Oh, equals to. Okay, then minus 2, minus 0, right? We don't need to put that. I just put it so you don't, because if you don't put it, somebody might ask, where did this go? Because they think this minus 2 is this minus 2. So let's just put it for now. All right, so we substitute and substitute directly, or you could simplify first, your choice. Okay, here we substitute directly immediately, right? Here let's simplify before we substitute. Then you can decide which one is better for you. Okay? So simplifying first means we keep this here, we take these guys away. So 2y plus 3, is it okay to just do that? Is that okay? It's equal to, minus 2 is already here waiting for them. So this one will be minus 2 dy dx squared. You see, there's a difference between the two. Okay? There's a difference. This is dy dx times dy dx, that's dy dx all squared. It's different from this one. Please take note. Alright? So from here you can substitute. You don't want a complex fraction. Even this is already a fraction, right? So you want to be very careful. So we can substitute here. Or you can bring this before you substitute, up to you, like I said. So this will be equal to negative 2 times, is that lazy girl? Yani, that's caring. 2y plus 3 all squared. Can you see that? So now, this negative will be absorbed by this, right? But this negative remains. So this is negative 2 times 4 brackets x plus 1 all squared divided by 2y plus 3 cubed. Can you see that? No, squared. And add. If we had used quotient rule, they would have been squared here, right? And you probably need to do some substitution, then there will be cubed, because when this guy comes now, it's going to be cubed. So finally, the dy dx, no, the 2y dx squared is to be isolated. Oh, before then, this should be merged. So we have, anyway, let's merge it. So we have minus 8 over there. So we have minus 2 bracket 2y plus 3 squared, yes? Then I have minus 8 x plus 1 squared, everything 2y plus 3 cubed. Okay? Don't expand. If you can factorize, you factorize and reduce. Otherwise, don't expand. Just leave it. Don't even think of bringing this out. It's pointless. What do you want to do with it? There's nothing here to cancel. So it's okay. Any questions? Understand? I'll ask you to try one. Maybe you can leave space for this and try one yourself, because we have very little time. And I want you to try one. So for the first few lessons, for the first few minutes tomorrow, we'll practice more on this. Okay, but even if I have to spend the whole of tomorrow to make sure everybody gets that knowledge, okay,